Hi everyone. In this video we're going to review some basic trigonometric identities that will help you to be able to prove more advanced trig identities later on. So I'm going to start with the coordinate plane, and I'll draw a terminal arm with an angle theta and drop the vertical, thus creating a right triangle. I'll label the right triangle in our customary way, with the base of the triangle being x, the height being y, and the hypotenuse being r. Okay. From there, we know from standard right triangle trigonometry that sine is equal to y over r, so opposite over hypotenuse. Cosine is adjacent x over hypotenuse r. Okay, and then from there, the cosecant, it would be the reciprocal of sine. So if sine is y over r, then cosecant is r over y. We can also write the reciprocal of y over r as 1 over y over r. But of course, 1 over y over r is really the same thing as 1 over sine. Okay, so at the end of the day, cosecant is 1 over sine theta. I don't think that comes as a surprise. Similarly, if cosine is x over r and secant is the reciprocal, then secant would be r over x. The reciprocal of x over r can also be written as 1 over x over r. And at the end of the day, sec is in fact defined as the reciprocal of cosine. Okay, so that's what we've discovered. Okay. Well, we haven't really discovered. We already knew this from the beginning. Okay, so now let's take a look at tan. Tan is opposite y over adjacent x. Okay, now bear with me here, but y over x can be written as y over r times r over x because the r's cancel and I'm still left with y over x. Now some people might say, well, why are you doing that? You're just making things a little bit more complicated. And to that I would say, well, just bear with me here. So if I have a product of two fractions, I can express that as a quotient as well. Now, normally we go this way, right? Normally we go, oh man, I'm dividing fractions. Oh, I can flip the second fraction and multiply the two together. So usually we go this way. This time I'm going this way. Why? Do you recognize this expression? Do you recognize this expression? Isn't this sine? And isn't this cosine? Okay. So that's precisely why I'm writing it that way. So tan theta at the end of the day is sine theta over cos theta. And you might have surmised that based on your study of unit circles. Okay, I won't bore you with the details of cotangent. Cotangent is, after all, the reciprocal of tan. And if tan ultimately is sine over cos, then cotan would be, flip it, cos over sine, right? Okay, we're good there. All right, so let me just tell you this. These three ratios are considered, or I guess not ratios, but these three identities are considered reciprocal identities. Okay, because they, after all, give you the three reciprocals, cosecant, secant, and cotangent. And then these two, although this is, I guess, a reciprocal identity, these are called quotient identities because obviously the right-hand side is a quotient. Okay, we're dividing two trig ratios. Okay, from there, let's move on to another aspect of this triangle, which is that these three sides are related to each other by Pythagorean theorem, right? It is, after all, a right triangle. So x squared plus y squared equals r squared. I've written it this way. Now, what I'm going to do here is I'm going to divide each of these three terms by r squared, okay? Because I can. That's not a good enough reason, really, okay? Well, we're trying to come up with a different kind of identity, and it involves getting 1 on one side of the equation. So r squared over r squared is equal to 1. Okay, so we end up with 1 there. X squared over r squared can be written as x over r all squared, and y squared over r squared can be written as y over r all squared. Okay, now of course I'm going to ask you again, do you recognize these ratios? Sure. X over r is in fact cos, so we've got cos squared here. Y over r is sine, so we've got sine squared there. So 1 is equal to cos squared plus sine squared. Okay? So this is actually a ratio that you need to be familiar, not a ratio, but an identity you need to be familiar with. Because this identity tends to crop up a lot when you're asked to prove more complicated or more advanced identities. Okay? All right, and I'll just show you a couple of other versions of the same identity, right? All I'm doing here is I'm subtracting cos squared theta from each side, And this version of the original identity here is just subtracting sine squared theta from each side. So you have to be accommodating of the different variations of the same identity. Okay, so sine squared plus cos squared equals 1. We've established that. Now what I'm going to do is I'll divide each term by sine squared, again, because I can, and because it's mathematically legit. So if I divide every term by sine squared, now look what happens. Sine squared over sine squared obviously is 1. Cos squared over sine squared, I wonder what that might be. Okay, do you remember one of the quotient identities as being cos over sine? And then 1 over sine squared is really 1 over sine theta all squared, right? And so 1 over sine theta is a reciprocal identity. Cos over sine is cotangent, so really I've got 1 plus cotangent squared, which equals the reciprocal of sine is cosecant theta, so cosecant squared theta. Okay, great, awesome. So we've got this guy right here, and we've got this guy right here. And these guys, wait for it, these guys are called Pythagorean identities, right? Because they all look like a squared plus b squared equals c squared, and c here is 1. A squared plus b squared equals c squared. Okay, now there is actually one other identity here that if you want to pause this video you can figure out, and I'll just give you a hint here. The way that I got this identity was I took this original identity and I divided each term by sine squared. Gee, I wonder how I might get the other identity. Okay, so if you think you might know how to do that, I would challenge you to do so. And here's the answer, right? 1 plus tan squared theta equals sec squared theta. So these are your Pythagorean identities, and we come to an end. What we have here are the quotient identities. Well, I guess we have quotient identities and reciprocal identities. These two are the quotient identities. These are the reciprocal identities. I should probably write that in there. Okay, hopefully you can read this. And then down below, where there are squared terms, we've got our 3 Pythagorean identities. Okay, and that is your brief introduction to the basic identities.